Hello, let's look at number 7. So, a projectile of mass m1 is fired horizontally from a spring gun that is initially at rest on a frictionless surface. The combined mass of the gun and the projectile is m2. If the kinetic energy of the projectile after fire is k, the gun will recoil with a kinetic energy equal to what? Okay? So, first of all, I need to let's go ahead and set this up. We know that this is a momentum question. And the initial momentum that we have before they fire is 0. Okay? And then that will equal to something like the momentum of the gun plus momentum of the projectile. Okay? We know that these two are going to cancel each other out. So one's positive, one's negative. Okay? But equal in value. So this of the gun, the momentum of the gun is going to be m2 minus m1. Okay? Because m2 is the combined, and we gotta subtract that projectile. And then this will be v of the gun. And then that's going to equal, or that's going to, we have this other momentum here, right? And that will just be m1 v. Okay? Now, the problem is, I want to solve for the kinetic energy, so I need to find this velocity first. Okay? So I need to find out what this velocity is before I can find this velocity, and then use that velocity to do 1/2 mv squared. There's a lot of steps here. Okay? So first of all, I need to solve for this velocity here. Well, I know that I have k, that is the kinetic energy of the projectile after firing. So I have k equals 1/2 m1 v squared. Okay, and this v is this one. Okay, so I need to go ahead and solve for v here. So I have 2k divided by m1 equals v squared, so square root. Okay, so now I know this one. So I can go ahead and set this next step. So m2 minus m1 vg plus 0 plus m1 2 capital K over m1 root. Okay? Now I'm going to go ahead and solve for this velocity here. Okay? So I'm going to subtract this. Okay? And I'm going to go ahead and put this as a negative. Okay? I know that this velocity is the opposite direction of this velocity. Okay? Which means that these two things here are equal. Okay? So I need to go ahead and solve for this velocity. Once I find that velocity, I can plug it into the kinetic energy formula to find the kinetic energy of the recoiling gun. Okay? So now I just need to divide by this m2 minus m1. So I have Vg equals m1 over m2 minus m1 root 2k over m1. Okay? So now I have my velocity, and I can go ahead and plug that into the kinetic energy formula. So I have Ke equals 1/2, well my m, remember, is m2 minus m1. Okay? And then I need to square this. So I have m1 over m2 minus m1 root 2k over m1 squared. Okay? So I'll have something like this squared, and then my square root will go away. Okay? And so that will kind of get all of that squared, everything being squared. Okay? So you notice I have a 2 over a 2, so that cancels. Then I have m1 squared over m1, so this m1 cancels with that m. And then I have an m2 minus m1 over an m2 minus m1 squared. So this squared goes away and this cancels. So this is equal to m1 k divided by m2 minus m1. Okay? And so the correct answer would be D. Yeah, that was a long problem. So this is definitely one that you might have to come back to after you've kind of done other things, because it does take a long time. Okay? You would be able to eliminate some of these just by thinking through it. You know that the velocity of the gun is going to be less than the velocity of the projectile. Okay, because you know that the projectile has to be less than the gun. Okay, so you would be able to maybe eliminate some of these, but that's definitely a tricky